Here in this video we will talk about how to design and analyze a cantilever beam that is fixed from left side and a force with magnitude of 100 Newton has been applied on the other free end of the cantilever. The length of the cantilever is 1 meter, the cross section is 1.1 meter by 1.1, it's square or rectangular beam section. And here these values are about the material properties corresponding to Poisson ratio and modulus of elasticity 2.07 multiply 10 to the power 11, and the unit is Newton per meter. The unit is matching with the unit of force and unit of length. Let's start modeling this cantilever beam in 1D dimension using Abaqus. Here is the user interface of Abaqus. Abaqus somehow is a confusing software. It's a software that needs to be practiced continuously, because if you get away from it for a while you may forget how to use it. So let's start with it. First, let's go to select the directory work. We are going to set our work directory. Here I have chosen this file. I have opened MS Abaqus in C, so that whatever I will do and save it, it's going to be saved automatically here in this file. Okay. Abaqus is consisting of these parts: property, power, property, assembly, so on. So here, in order to design the cantilever beam, we have to go through each one of the topics that are mentioned in this list. First, let's start with part. Part is the place where we can choose which dimension our model is. Is it 1D or 2D or 3D? Here, from create part icon, we can select it. We can select it which model we have. Or let's close this one. We will do it from here, from part manager. It's again leading us from create. It will lead us to the same window that this icon directly taking us to. Let's choose name beam or cantilever beam. Our beam is 1D, so here we will choose 2D. It's deformable, and we will choose a wire. And approximate size we will choose 50, or let's choose 25. This approximate size, it's about the size and scale of the grid on which we are going to model our beam. Okay, let's go to click on continue. Dismiss this one. Okay, it's our grid. Then we will go to create lines. So when we click it on create lines, here this one needing us to give pointers. We will give 0, 0 as x and y axis, then enter. Okay, then we will give the second point for our beam. Our beam is 1 meter, so we will give 1 for x, 0 for y, enter. Okay, now this is done, and then we will click on escape. Then here it's saying sketch the section for the wire. Okay, the sketch is done. We will click on done. Now automatically the model is ready. Let's go. Okay, about part we are done. We have already made our 1D model. We will go to property. Property is where we can give information about material properties such as Poisson ratio, elasticity, and so on. And also we can define our sections. First of all, let's go to material, or from material manager we can do same thing. We can go to the same window. Let's give a name to material. Let's give steel name. We will go to mechanical, elasticity, elastic. It's isotropic material. Youngest of models and Poisson ratio. These boxes or these cells where we go to feed them with these values. Okay, 2.07 E plus 11, Poisson ratio 0.29, Poisson ratio 0.29, yeah. Okay, now everything is done. And here description is where you can write down your notes on, or you can leave it empty as you want. Okay, it's done, still is done, then dismiss. Okay, we have to talk about section, create section. We will give square section name, square section. It's not solid or not shell, it's beam. Solid is use it when we have 3D model. Shell is use it when we have 2D, and beam is used when we have 1D. Okay, then we will choose beam, continue. Let's give a prof. Okay, let's go through this icon, create beam profile. We will give a name, square. It's rectangular, continue. We will give the dimension 0.1 meter by 0.1. Okay. Okay, material name is still Poisson ratio. Okay, we will give Poisson ratio again, even if you leave it empty. It's okay. Here there's another point. Material name is still. Still, it's a material that we had assigned before. If before we had not assigned anything, we could have assigned here again. But right now still is ready, so we will choose still. Okay. We can leave these things as it is. Okay. Okay. Now section is ready. We have to assign section. We will click on assign section. It asking us select the region to be assigned as section. We will select this one. Done. Okay, section is square section. Type is beam. Material is still. Everything is okay as we did in the previous steps. Okay. Right now the section is already assigned into the beam. Then okay, there's something else. For 1D beam, we have then after assigning section, we have to go through this icon, assign beam orientation. It's asking whenever we click on icon, we can read the note that is going to be written below. The notes below will tell us what to do. Here telling us select the regions to be assigned. Okay, we will choose this one. Done. Then we will click on enter. Now the orientation vectors are assigned, then okay. Okay. After property, we will go to assembly. We will click on create instance. Okay, we can make our beam dependent or independent. So let's make it independent. Okay. Then let's go to another step. Okay. Step here, we can create our step here, or we can create from step manager. From step manager, we will create another step. We will give it name as step 1. It's static general. I'll continue. We will leave everything as it's blank. Okay. Now we have 2 steps. I'm going to explain what these 2 steps are for. Right now we have a beam. So before everything, our beam needs to be fixed here. So even without applying force, the beam is already fixed here. So that fixed part or that fixed portion of the beam is going to be included in initial. Then we are going to apply a static force. So that static force is not there from the beginning of beam, so it's there on some step of the beam. So that forest is needing to be included into another static step which we have assigned it right now. Okay, now it's okay, then we will click on dismiss. After step you will go interaction. We don't have to go to interaction, we'll go to load. From load we will give boundary condition. We will give a name, fix it. Okay, look, here it's a tricky point. Fixed is going to be fixed from the first step, initial step. Then symmetry, we'll choose this one. Mechanical, this one. Symmetry, anti-symmetry, and caster, continue. Okay, we have to select region for boundary condition. We will select at this point. Okay, done. Then we have to choose encaster where displacement around x, y, z are 0 and then rotation around x, y, z are 0 too. Okay. Then for